Good day everybody, we got a beautiful question. We have a semicircle and this circle is inside a trapezium. So there is a point of contact over here, a point of contact and a point of contact, a point of contact here. So let me take these points as A, B, C, D, E and F. Now if I were to take O, then AO is given to be as 8 units, where O is the center of AB, right? Okay, fair enough. So this point is, or I should say that line segment is 8 units. Now we've been given the two lengths, right? The parallel sides, the two parallel sides lengths are given. We've been given to be, this length is B units, this entire length is A units, right? So that is given. We are expected to find AB. Now what I wish to do is, I would like to first draw a line connecting C to this bigger base, right? If I were to do that, I would get a rectangle. So this is step 1. I've already started the solution here. Now let us, before we could draw that line, we make a few observations. Okay, clearly we see that the circle, when I say semicircle, when I say circle, it means the semicircle. You see that the circle has a point of contact at E and at F. Now there is also a point of contact over here, so let me take this point of contact as G. Okay, foremost I am considering these 2 point of contacts, E and F. So this would mean there is a tangent at E and at F. Now by two tangent theorem, tangents drawn from an external point to the circle are always of equal length. So this would mean DF will be equal to DE, right? So this distance will be same as this distance. Also, okay, we observe that there are two tangents at E and at G. So this means CE is equal to CG, right? So this is equal to this. So that's the first line of observation. Now this entire length, if you can clearly see that this entire length is A units. So let me just now draw let us draw a line from C to AD. Okay, so let us draw a perpendicular line. That's a better way to say perpendicular line. So from C I am drawing a perpendicular line. Right? This is perpendicular line such that I am taking it as H, such that CH is parallel to BA and also CH is equal to BA. Since BA is equal to 16, this is 8, so this also will be 8 units, right? And so the entire length CH is going to be 16 units. So this entire length is going to be 16 units. Now I want to know what is DH. Now this entire length is A units. Now this is B units. From A, if I subtract B, this entire length is going to be A minus B. This is going to be A minus B, right? Now this is perpendicular line, so this is 90 degrees. So what I can do is, let us consider, I'm going to consider CHD. Let us consider triangle CHD. So using Pythagoras theorem, so I'm using Pythagoras theorem. Why am I using Pythagoras theorem? Because it's a right angle triangle. So CH squared plus DH squared is equal to CD squared. CH is 16 squared plus DH is A minus B squared is equal to CD squared. Now I need to get what is CD. Alright, so for the time being I'm just placing CD squared here. Okay, now clearly how are we going to get CD squared? Now this length is B, so this is also going to be B, right? This entire length from here, this entire tangent, the tangent is being drawn, so this entire tangent is going to be B. It's taken as, is given as B, so this entire thing is going to be B units up until here. And if I were to take this as this entire length, say for example from here a tangent is drawn, so this entire length is given to be as A. So if this entire length is given to be as A, this is also going to be A. So this entire segment is going to be A plus B. Well, it's a little bit tricky, but we have to see these things. If we don't see these things, we won't be able to solve this question. And remember, visually we cannot judge it. We can only judge from the concepts that we have already studied. What are the concepts we have already studied? This is a circle and a line is hitting the circle. And there's a tangent at E, tangent at F and tangent at E. So a tangent is created from an external point. So thereby, by two tangents theorem drawn from an external point, they are equal. So that is the only fact that I have applied here to come to a conclusion that this is going to be A units. So CD is going to be a plus b the whole squared. So this is a minus b whole squared. You expand this, is a squared, you get negative 2ab positive b squared. Of course you got a 16 squared here, and this is going to be a squared positive b squared positive 2ab, right? Now this can be cancelled, this can be cancelled. So what do you got? You got 16 squared. I'm going to push this 2ab to the other side, negative 2ab. So you have 2ab positive 2ab, which is nothing but 4ab. You got 16 squared. I'm going to multiply it as 16. 4 divides here 4 times. 6 times 4 is 24. 2 4 ones are 4, 5, 6. 64 is equal to ab. This is exactly what we want. We want to find out the product of the two parallel sides, and we have found that to be as 64 units, right? So that is the solution. Now this is a lovely question for the fact that we are actually applying some interesting concepts that we have studied in geometry. Thank you everybody. Please like, share, and watch the next video. As I always mention, the more you know, the better you are. Thank you.